In this video, I'm going to show you how to find definite and indefinite integrals. First, let's go over the notations. So if we are deriving a function, we're deriving a function f of x, this would equal to f prime of x. Now, if we are finding the integral of f of x, this would equal to capital F of x plus a constant c. Now, the reason we have a constant c here is because if we were to find the derivative of f of x plus c, so we're finding its derivative, we know that if we were to integrate f of x, we will get capital F of x. So if we were to find the derivative of the capital F of x, that will give us back f of x. So this will equal f of x plus derivative of a constant is going to be 0. So this would equal to f of x. Therefore, when we have a constant added, even if there's a constant, we're still going to get f of x because the derivative of a constant is 0, which is why when we integrate, we make sure to have the constant c here. And this is what we call an indefinite integral. Indefinite integral equals to integral of f of x over a region that has no limits, which would equal to f of x plus c. Definite integral means that our function has an upper and a lower limit. Lower limit is usually a and upper is b. And if we were to integrate this, first what we do is we integrate the function f of x and we get the capital F of x. And then we evaluate this function over the limits a to b. And this will give us the difference between f of b, between the upper and the lower limit. Now let's do some examples. Let's say we're integrating a constant 5. What would be the integral? Now to do this, first we have to notice that this is an indefinite integral that has no limits. Therefore, when we integrate this, we are going to add c to our answer. So when we integrate a constant, this would equal the constant times x plus c if it's indefinite. So when we derive ax plus c, we will get a as the answer. So integral of 5 is going to be 5x plus c. Now let's integrate a variable. Let's say we're integrating x squared. Again, this is an indefinite integral, therefore we're going to add c at the end. The formula to find the derivative of a variable that has a power is equal to x to the power plus 1 over the power plus 1 plus c. So integral of x squared is going to be x raised to the third power over 3 plus c. Now what if we have a definite integral? Let's say we have x raised to the 4th power. And the lower limit is going to be 1 and the upper is going to be 3. So first thing we do is we integrate x to the 4th power, which is going to be x to the 5th power over 5, and then we evaluate the integral over the borders 1 and 3, which will give us, what we could do here is we could take out the constant 1/5 out of the equation, and we could just plug in 3 and 1 for x. So we're plugging in 3 first, we get 3 to the 5th, and we subtract 1 raised to the 5th. So what we get is 1/5 times 3 to the 5th minus 1. That's our answer. Let's integrate the given example. 15t raised to the negative second power plus 4t cubed minus 5t raised to the negative 10th power. This would equal to 15t raised to the negative 2 plus 1 power over negative 2 plus 1 plus 4t raised to the 3 plus 1 power over 3 plus 1 minus 5t raised to the negative 10 plus 1 power over negative 10 plus 1 plus c. The rest will have to be simplified. In this next example, we're going to integrate 2 times square root of x to the 6th power plus 3 times 8th root of x to the 5th power over the region 2 to 5. Now, in order to integrate this, let's first rewrite this in a form that would be easier to integrate. So we have square root of x to the 6th power that could be rewritten as 6 over 2 plus 3 times x to the 5 over 8th power. Now this could be simplified and become 3. Now we could start integrating. So integral of 2x raised to the cubed power is going to be 2 times x to the 4th power over 4 plus 3 times x raised to the 5 over 8 plus 1 power over 5 over 8 plus 1. And now this would be evaluated over the region 2 to 5. So what we do is we first plug in the 5. This could be simplified and become 2. So we're going to get 1/2 here. We're going to get 5 raised to the 4th power plus 3 times 5 raised to the 13 over 8th power divided by 13 over 8 minus, now we plug in 2, so we get 1/2 times 2 to the 4th power plus 3 times 2 to the 13 over 8th power divided by 13 over 8. The rest will have to be simplified. In this example, we are integrating 4 over x to the 7th power plus 2 over cubed root of x to the 10th power. Now, this one is also better to rewrite. So we're going to get 4 times x raised to the negative 7th power plus 2 times x raised to the negative 10 over 3 power. This would equal to 4 times the integral for x to the negative 7 is going to be x to the negative 7 plus 1 over negative 7 plus 1 plus 2 times x raised to the negative 10 over 3 plus 1 over negative 10 over 3 plus 1 plus c, since it's an indefinite integral. The rest needs to be simplified. In this last example, we are integrating 7 over x squared minus 1 over x. This would equal to, this should be first rewritten, and this would equal to 7 times x to the negative 2nd power minus x to the negative 1 power. So when we integrate this part, we will get 7 times x to the negative 1 power over negative 1 minus, now when we integrate this, notice that if we add 1 to this power, so if we say that this would equal to negative 1 plus 1 over negative 1 plus 1, we will get a 0 in the denominator. So in this case, when we have an x raised to the negative 1 power, or 1 over x, the formula for that is integral for 1 over x would be natural log of x plus c. So in this case, we're going to have x to the negative 1 power to be natural log of x. And then we're just going to add c since it's an indefinite integral. The rest is simplified. If this video was helpful, please subscribe to my channel.